Right, here is our mini lesson on equivalent fractions. We're going to go over how do we find equivalent fractions, what are they used for, and kind of this idea of using this number 1 but in different forms. So let's get into it. Our one definition for equivalent fractions, this is your blank spot in your notes, says that equivalent fractions are fractions that look different. If I get my underline, there we go. That look different, but they still represent the same value. Okay, that's a key word. Or the same part of a whole. Okay? Right, what do we mean by this, right? If I were to, think of like a pizza. If I were to cut a pizza up into fourths, and I was to say, hey, I'm eating 1/4 of the pizza. So I'm eating that portion right there. Okay? An equivalent fraction looks like this. Some people cut their pizzas. That's a really bad pizza. Let's try that again. Some people cut their pizzas up into eighths. Okay? So we get 8 triangles. Okay? If I was to think, how many slices would I have to eat the exact same amount as before? Right? This time, I'm still going to eat 1/4 of the pizza, but now it looks like I'm eating 2 slices. Okay? So this fraction would be like 1/4 of the pizza. That's how much I ate. For here, just because the amount of slices is different, it doesn't mean I ate less pizza. It just means it was kind of cut up differently than before. Okay, this is what equivalent fractions are. Either way, I'm still eating the same amount of pizza. That's what it means by eating, like, this represent the same value. Okay, so we're going to have this idea of a fraction equal to 1. And here's what we mean by that. 1 is a really important number when it comes to multiplying. Okay, we call it, in later grades you'll hear it called the multiplicative identity. Don't worry about that right now. But really what it's saying is if I multiply any number by 1, I'm going to get back the same number. Right? 3 times 1 is 3. 56 times 1 is still 56. Okay, I'm not changing the value. I'm just multiplying it by 1, keeping it the same. Well, we have some different forms of 1 that we can use, right? 1 as a fraction is this, 1/1, because why? Well, a fraction is just 1 divided by 1, which is 1. Okay, but also there's more fractions that I could divide that still equal 1. For instance, 2/2. Right, a fraction just says, hey, it's a number of parts divided by a whole. If I have 2 parts and there's 2 wholes, right, 2 divided by 2, that's also equal to 1. So if we take our 3 example here and we multiply it by 2/2, right, any fraction can be written over, or any number can be written over as 1. Okay, this now becomes 6 halves. Okay, it looks different, right? These two look different. But if I were to take 6 divided by 2, I'm going to get 3, which that's what it was before. Okay, this might be a little confusing, this concept of 1, but it ends up being one of the most important concepts we have when it comes to multiplying in math. Okay, 3 pizzas might look something like that. 6 half pizzas, right? Here's my pizza halves. Right? Yes, they look different initially, but if I were to combine these two, well, that's 1 full pizza, that's a 2nd full pizza, and that's a 3rd full pizza right there. Either way, I have the same amount. Okay, so when we find equivalent fractions, we need to multiply the the numerator and the denominator by the same value, right? Multiply it by 2/2. Multiply both by 4. Right, times 4 times 4. This keeps the value the same because really all we're doing is, again, multiplying by 1. So if I were to write an equivalent fraction for 3/4, right, as long as I follow that rule, I'm good to go. So I can choose any number. Let's choose 5. Why not? Okay, I'm going to multiply the top by 5. 3 times 5 is 15. To make sure this stays the same value, I also need to multiply the bottom by the same. right? Multiply the top, multiply the bottom, both by 5. 4 times 5 is 20. 15/20ths is an equivalent fraction of 3/4. I could simplify it out, divide it, and I would still get 3/4. Okay, same thing here. Let's multiply this one by 10. Times 10 times 10. You could choose any number to multiply by. I'm just choosing that. 5 times 10 is 50. 50 times 10 is 500. And if I were to divide it out, I'd still go back to 5 over 50. Okay? What's cool about this one, 5 over 50, is this also works for dividing. Okay? This is simplifying. Right? I could have divided both by 5, and I'm still going to get an equivalent fraction. Okay? There we go. In examples I and J, notice it's already kind of started something. Okay, it's already giving us what we want to go to. So if I think about this, right, how did I go from 10 to 40? Well, I multiplied by 4. We know that I have to multiply the same on top and bottom for them to be equivalent, meaning I have to multiply some number by 4, which gets me to 8. Well, what number times 4 is 8? That would be 2. Right, 2/10 is equivalent to 8/40. Looking here, right, 7 to 49, that's times 7. Our rule says multiply it by the same on the bottom. 5 times 7 is 35. Just like that. All right, here's a couple try problems for you. Pause the video, take some time to do that, and we'll go over the answers in a second. For 1/7, we can multiply it by anything. Let's choose 4. Why not? I'm going to multiply the top and bottom by 4. 1 times 4 is 4. 7 times 4 is 28. Look at that. We have an equivalent fraction. If you chose a different number to multiply by, totally fine. Just make sure you're doing it on top and bottom. For number 8, we're starting to get into the ones that have already kind of given you what the next one is. To go from 2 to 12, right, that is times by 6. So I have to multiply the bottom by 6, because that's my rule. Whatever I do to the top, I do to the bottom. 11 times 6 is 66. For this one, kind of working backwards here, 5 to 20, that's times by 4. I have to think to myself, what number times 4 is 12? That number is 3. Finally, for number 10, we could go either way. Let's multiply up by a little bit. Let's multiply by 20. Why not? Times by 20. All right, 25 times 20. You don't have to choose this big of a value. I did to show you any value is going to work. Okay, that's 10, 50. I get 500 over 2,000. Again, I could have divided here both by 25, ended up with 1/4. Any one of those would simplify to 1/4 or to 25/100ths, 500 2,000ths, anything like that. So those are our try problems and at the end of our lesson.